Yeah.
Sure. Okay. So we talked about AWS well-architected framework. So I'll say AWS architecture. So this is the same thing which will be followed across any deployments, be it a data analytics solution, or maybe anything related to storage or anything related to web application. So this will be definitely followed. That particular pillars or maybe architecture concepts I talked about as high availability, high scalability, fault tolerance, cost optimization, and performance. So all this are connecting to different pillars of well-architected framework that you could have already seen. Something like operational excellence, reliability, performance, cost, or few other things, security. Few other things will be connected to this AWS architecture pillars. Okay. So what is autoscaling group does is autoscaling group, say I'll put AWS at the outside and autoscaling group inside. So this actually provides all the services that we talked about, all the architecture that we talked about, high availability. How do you get high availability? Using availability zone. Autoscaling group also provides high scalability, that is using autoscaling and scaling policies. Fault tolerance using load balancer. Then it comes cost. You have the minimum, maximum, decide, and it is based on CPU or memory utilization. It increases or decreases. And finally, you have security, that is provided by IAM. You can define IAM roles, IAM uses that can be attached to specific services that will take care of only specific access is required given. So this is about autoscaling groups. Why autoscaling groups is very popular, or maybe it does the purpose, is because all the 5 pillars of AWS well-architected framework is already covered in this autoscaling groups. Be it operational excellence, reliability, performance, cost, or security, it is already covered from autoscaling groups. Okay, because can you tell me what exactly we are trying to deploy here? Is it a container service or is it a EC2 service?
EC2 service.
Correct. Basically, autoscaling group mainly targets for EC2 deployments. When I say EC2 deployments, it will be mostly clustered, right? It is only about vertical scaling. If you really look at it, it is a horizontal scaling only. But if you really look at the system, if you consider EC2 as a simple compute, then it becomes like a virtual CPU. So it is like you're adding multiple EC2 instances to the workload based on your CPU or memory. So it is basically for the EC2 deployments. But we will not be just deploying EC2, right? What is the purpose of deploying EC2 instances? So EC2 instance deployment purpose is running an application, right? Then only customer will be able to access your service and you can make money. You deploy some application, probably you sell some services, you sell some products, you promote something, you get customer access and you get paid for it. That's what is the whole and sole purpose of running an application or deploying an EC2, running a workload. So nowadays, what kind of deployments are going on? Is it a traditional deployment or Docker-based deployment? Is it traditional or container-based deployment? Because
Container based nowadays.
container-based, almost 99% of the workloads or applications are already containerized or already deployed in Kubernetes or any other container orchestration system. Okay, we don't need to talk about traditional way of deploying because it is basically using systemd service. If you are using Linux, when I say systemd, it is nothing but it is a system service, system daemon. It is called system daemon. It is a system service. You can run only one version of the application at any point in time on a single EC2. So if you want to run two versions of the same, you need to have two different EC2. And you should also, but just for running one service, you're going to be using this complete EC2 instance. Got it? What are we missing is we are missing the efficiency, cost, everything is compromised. That's the reason why people went ahead with container-based deployments. What is container-based deployment? Basically, it abstracts your operating system and then puts a small piece inside that you run the application. That is why it is isolated, lightweight, and portable. Any questions on this, Srini or Vikas?
No, shit.
No, Shankar, I got.
Okay. When we deploy this as a container into the system, we get the opportunity to run multiple containers within the system, within the single EC2 instance. Because it is a lightweight, it is portable, it is easy to get the deployment done, and it is probably taking few seconds to deploy. How much time EC2 instance will take? At least minimum 4 to 5 minutes of time to start the application, to start the EC2 instance and start the application. But whereas with container, it hardly takes few seconds to complete. Okay, now again, we are going to container orchestration. Why orchestration is required? Forget about Kubernetes, Docker Swarm. Why container orchestration is required? Because it is a standalone, right? It is standalone. For example, you think about your laptop. It is running some hundreds of applications here. No one is doing anything here. No one is looking at whether the power is connected or not. What would happen after some time? Definitely, laptop will get shut down. Or if some performance issue comes up, automatically it will restart. So the same thing will happen to the servers connected in the rack in the data center. Because we don't just leave it like that, because we have 24/7 power and somebody is monitoring this one using a centralized monitoring system. What each virtual machines or each physical machine is running, how it is behaving, everything is being watched. So there is an infrastructure team which will manage everything. So when it comes to containers which are running inside a small virtual machine or big virtual machine, container is a small size. So it is very, very much possible that it gets killed or restarted or behave very slow. So all these problems may occur with respect to containers, because container is also exactly same as your virtual machine. The only difference is it doesn't have the OS installed on it, and it uses a system kernel. So it uses a host operating system. It doesn't have any separate operating system which can just run separately on a single physical hardware. It can only run on top of the existing virtual machine. So any questions so far?
No, Shankar, I got.
No, Shankar.
Okay. So containers serve the purpose of one important problem or one never-ending problem was consistency. That is the reason why we initially went with VM. This we discussed many times, and then VM is heavyweight. That's why we went with a container. Container is lightweight. What we are achieving is consistency across environments, anytime consistency. Because whatever you provision, it is based on a specified image or fixed Docker image. Whatever you do on top of the Docker image is the only difference. And that varies from time to time. So we don't have to really worry about getting the packages installed or the application installed and running the Docker container. One of the issue previously was we have a physical machine. We need to reinstall operating system multiple times to have consistent environment. And even if you have a VM, the boot time is more, and you need to depend on people to create a VM. I'm talking about physical machine on top of that virtual machine, not EC2. I'm not talking about EC2. So EC2 is in cloud. You don't need to worry about provisioning it. You can use Terraform to provision the resources. But olden days, it used to be a virtual machine on top of a physical machine, and there is a lot of overhead to maintain or manage the particular system. So to overcome all that, we have come across multiple, what do you say, multiple changes. So we are currently on the container world, and we just need to worry about only how to manage container orchestration. Okay. When we talk about container orchestration, say you should probably, okay, I'll draw the same picture once again here. This is AWS, which is managing autoscaling group. So think about only autoscaling group, okay? And here it is Kubernetes, which is managing the whole container orchestration. Here it is EC2. Autoscaling group is the one which is managing everything. So here you will have, what are these? EC2 instances. What are the different things that we manage here? Scaling, availability, fault tolerance. Without this, I mean, we can't really have a reliable solution or powerful solution or high performance solutions. So cost and security. So exactly with respect to Kubernetes, the whole thing on this left-hand side is managed by AWS, right? There is no point in having master node. So you probably will not understand at this point, but when I talk about Kubernetes, you will probably get a connection. You don't need a master node because master node is kind of your AWS, which is managing the auto scaling group. So somebody has to be there to even manage auto scaling groups. It's a managed service, right? Auto scaling group is a managed service. So you should probably have some understanding of what is a managed service in AWS. Even if you say EC2, it is not just like lying somewhere and then you are using it. It is being managed by AWS. How many EC2 instances that you can provision? What is the maximum size you can provision if you probably set some limits? So when you provision a machine, what is the AMI? If you probably give a wrong AMI, it will not provision in Terraform code. So like that, everything is managed by AWS here because you just need to work only on the worker node. These are all the stuff that you need to just do it. Because see, scaling, you don't do it. Availability zone, you don't do it. Fault tolerance, you probably use again a managed service, which is load balancer. Cost, again, you use the minimum, maximum on decide count. Security, use existing services like IAM. Okay, when we go to Kubernetes, definitely at a high level, architecture level, there are two things. One is manager node and worker node. So when we say node, what exactly it is?
Container.
No, when we say node, it is EC2 instances, a virtual machine.
Okay.
Okay, it's a master node. Say I'll write it as master. This is worker. So here, Kubernetes as a software that is running on a particular machine. If you are deploying Kubernetes, you should deploy it on a single EC2 or multiple EC2 in order to achieve high availability. That becomes your master node. So wherever you deploy your Kubernetes, it becomes a master node. On AWS, it is a managed service, that is EKS. So you should always understand there is a master node, which is again highly available, highly scalable, and fault tolerant. And it manages the worker nodes within your Kubernetes operating system. So when I say Kubernetes operating system, it is nothing but Kubernetes container management system. Kubernetes container orchestration system or container management system. So you should understand this way. What Kubernetes does is it actually follows all the pillars or all the architecture concepts: scaling, availability, fault tolerance, cost, and security. So everything will be managed by even Kubernetes because that's the most important thing in terms of cloud. Any doubts at this point?
No, sure.
So you said about EKS.
So
So EKS is like a Kubernetes, right? Kubernetes service.
Kubernetes managed service in AWS. Similarly,
Okay.
you
In
have
AWS.
Elastic Kubernetes service. Similarly, you have Kubernetes service in Azure, that is Azure Kubernetes service. On Google, it is Google Kubernetes Engine, GKE. So where you don't have to really worry about managing the master node, installing Kubernetes. So you don't have to really worry about managing the master node or installing Kubernetes. In case you are setting up your Kubernetes, you need to think about your master node. I'll say master node, and then how master node are connected and acts like a single master, and which manages the worker node components, worker nodes. So I'll say worker. There are different terms used for Kubernetes architecture: master node, worker node, or I forgot the word. I mean, do you remember, Vikas? Anything? Yeah, control plane and worker plane. That is also we call it as. So ultimately, each worker node is EC2 instance. Each master node is EC2 instance. When we talk about Kubernetes cluster, the whole thing becomes a cluster. You guys understand what is cluster, right? Cluster is nothing but a network of machines connected to each other and behaves like a single machine. Basically, it will require some services to be running, or agent must be running to make sure agent will be running on these machines to make sure they communicate to the master node, or master node can communicate to the worker node. So even in case of ECS, there is an agent which is running on EC2 that will take care of that. That will be used to take care of the EC2 instances by ECS. Okay. Any questions at this point?
Shankar, all we are talking about most of the times only under Linux only, right? Is Windows, can we have the containers?
Containers in Windows, but there is no difference as such with respect to containers on Linux or Windows.
Okay.
You can go on mute. Okay, thank you. Okay. Again, when we talk about ECS, there is auto-scaling group inside. And again, everything is as per the. So basically, if you look at it, the same thing, if you go a little up, if you want to deploy ECS, then here on top of this, ECS comes into picture. So ECS will ultimately use auto-scaling group for managing or scaling the EC2 instances. ECS will take care of running the containers on the virtual machines, on the EC2 instances. Hope it is clear. So ASG, Autoscaling Group, manages the scaling of EC2 instances, whereas ECS manages the running container inside your EC2 instances. So you may be having a question whether Kubernetes or AWS AKS contains autoscaling groups. What is your thought process on this? Yes, it is very much required, even in terms of it is Kubernetes or AWS AKS. In terms of Kubernetes, it will be a cluster autoscaler. That is another service which is provided by Kubernetes itself, or maybe the third-party service that is called cluster autoscaler. So all of these things you need to be familiar before we do a deep dive into Kubernetes. Any doubts at this point?
No, Shankar.
Okay. How Docker file is written? It's a plain text file, right? Docker file. Docker file is a base for running Docker containers. What is the workflow for Docker container? Docker file, Docker image, then push and pull and run the Docker container, right? You have any doubts on the workflow?
No, Shankar, we got it.
No, Shankar.
Okay.
Create
So
a Docker.
Kubernetes, it is not a Docker because Docker is one of the container system. Similar to that, there are multiple service providers or multiple different companies provides container management system containers like Containerd or Rocket. There are so many different providers available for containers. So Kubernetes, it is not just only Docker, it supports all type of containers. So here we basically use a YAML file for defining the pod. Pod is the smallest unit of your Kubernetes, which contains one or more containers. We'll talk about what is container. Container is nothing but a small application. You can run multiple applications also inside a single pod. So pod is the smallest unit inside your Kubernetes. So when we say pod, think it as a single container as of now. Say container one is a pod one. What exactly is the concept behind well architecture framework? High availability, high scalability, fault tolerance, cost, and performance.
Security.
So ultimately, all the features are provided by Kubernetes. Autoscaling, you also set the replica set. So here it is, which is nothing but a replica set. Autoscaling. For accessing, we call it as services. And we'll talk more about what is there inside Kubernetes tomorrow, because you can go ahead and stop the recording for now.